Question 3. A student investigated the reaction between magnesium and excess hydrochloric acid. Figure 1 shows the apparatus. Okay, so we've got acid in there, magnesium. So the acid's reacting with the magnesium. We're getting bubbles there, so there's a gas produced. The gas is hydrogen. In this case, it will escape here, go up the tube, and it will push the gas syringe that way. Okay, and we're recording it. So this is the method used. Pour 50 centimeters cubed. Okay, add a piece of acid, add some magnesium, insert the stopper and delivery tube, start a timer, collect the gas produced in a gas syringe, record the volume of gas produced every 20 seconds for 2 minutes. Repeat steps 1 to 5 with higher concentrations. Okay, give the independent variable and one control variable in this investigation. So the independent variable is the thing that we're changing, and the control variables, and one control variable. Control variables are things we keep the same. So we're changing those and we're keeping the same. So what do we got? Well, we are going to collect the gas. So what do we do when we repeat? We repeat with higher concentrations of hydrochloric acid. Okay, so the independent variable is going to be the concentration. Concentration of hydrochloric acid. One thing we keep the same. Well, let's have a look here. Method for 50 centimeters cubed of hydrochloric acid. Yeah, we're keeping the time the same, but the main one here really is we're keeping the volume the same. So the volume of hydrochloric acid. There'll be lots of other things we're keeping the same, like the temperature, the length of the magnesium, the surface area of the magnesium. Be careful in saying amount, the shape of the magnesium, but they tell us the volume in there, so that's the most obvious, most straightforward one. The table below shows the results from the first experiment using hydrochloric acid with low concentration. Okay, got a table there. Complete. Figure 2. You should plot the data. In fact, plot the data, and we've got to draw a line of best fit. Report 00 has been plotted for you. Okay, so we've already got 1 point. So let's have a look at the graph. I can get this all on one page, can I? Not quite. That's a pain, isn't it? Time of seconds is 20 and 48. So 20 seconds is here. If I got to 40 there, okay, well I just need to check what, I might look on the side. So 20 is here, I know it's going to be on this line. That's 50 there. So there's 1, 2, 3, 4, 5 little squares, make up 10, so each of these must be 2. So 52, 54, 56, 58. So it's going to be there. So 58 is going to be, it was 48, wasn't it? 48, sorry, it's going to be here. 40 and 72, so we just go to 40 there, up to 70, which is going to be here. I might just on the side, so 70, and that's going to be 72, so it's going to be there. 60 and 90, so 60 is here, 90 is up here. 1897, where's 97 going to be? So 90 is there, 92, 94, 96, 98, so 97 is going to be in between those two, and this is going to be at 80 across, which is here. So 80 up to there and there. 198, which is going to be here, and 120 and 98, which is going to be there. Okay, so I'm happy that I've plotted my data, and I've also got 00 down here as well. Now, that's clearly not a straight line. Okay, what I don't do either is I don't do dot to dots ever. I don't ever as well do horsetail. That weird thing where you start doing that. It's like drama, like an art sketch. Okay, so what I'm going to do here is I'm going to try and, it's quite hard to visualize where it is, but I'm going to try and just go over a single smooth line. Now I would really, I'd use a pencil for this, but I have to use a pen so that you can see it clearly. What I'm doing first of all is I'm just trying to sketch where that line is going to go. I'm just practicing just to get a little bit of muscle memory, nice and smooth curve. And once I'm happy, I'm just going to draw it straight on. Okay, now it happens to go through some points. It doesn't have to. Okay, also remember I've been doing this for quite a long time, so I have quite a good muscle memory in terms of drawing these curves, so I'm quite happy with that. If I wasn't happy with it, I've done it in pencil quite light, I'd just rub it out and do it again. Okay, what I'm not going to do, I'm not going to be tempted into trying to do this, do it in bits. Okay, because that will not come out well. Okay, do one smooth curve. Also be careful at the end here. Sometimes the tendency is to draw a line and have it doing that at the end. Okay, it doesn't, this graph does not go down at the end at all. Okay, so be careful with that. Right, how does the rate of this reaction change with time? So when we see rate, okay, what we always think of is rate is related to steepness and gradient. They're both, rate, steepness and gradient are really the same, they all mean the same thing. So how does the steepness change with time? And use the table above, and we're going to tick, so we're going to use the table above, and we're going to tick one box. Okay, so what happens to the steepness? So the table bizarrely doesn't help that much. The easiest way to see it is on here. So the rate is definitely decreasing. The steepness is decreasing of this. So the steepness is decreasing. If you are walking up this slope, imagine, I quite often think of graphs as hills and valleys. If you're walking up this, it's really steep to begin with, and by the time you get up to the top here, it's less steep. Okay, and the arrow is the direction you're looking. So the steepness is definitely decreasing. Even though you're going uphill, the steepness is decreasing. And if we're happy, the steepness, another word is gradient, and another word for the same thing is rate. So the rate is decreasing. Looking at the table, you can spot that because the size in jump, that's 48, it goes up. This goes up from 48 to 72, so it's a small jump. This one goes up even smaller, and now it's not going up at all. So the jump each time is getting smaller. So the step is getting smaller, which means the rate is getting smaller. So the rate decreases for definite.